Welcome to Setting Course, an ABS podcast, where we're charting the future of the marine and offshore industries. I'm Brad Cox, and we're recording live from the show floor at OTC 2026 in Houston, Texas. Floating gas has had about a decade of operations behind it, but deploying it in harsher conditions raises a different set of challenges, especially around station keeping, disconnectability, and long-term viability. To explore that, I am joined by Arun Duggal, Head of Mooring Solutions for MODEC and President and Country Manager for MODEC America. And I do want to mention award winner of the OTC Heritage Award last year. So, Arun, thank you for joining us today.
All right, well, thank you. And it's really an honor to be here today. I've had the opportunity over the last 30 years to present at OTC, but this is really the first time I've spoken on a podcast and actually from a booth. So I'm looking forward to this new format of talking about things I've always loved working on.
And it's also great to have Matt Tremblay, ABS Senior Vice President of Global Offshore. Welcome to the show, Matt.
Thanks a lot, Brad. Happy to be here.
So, Arun, let's get us started here. You know, when you look at the next wave of floating gas opportunities, what makes them more technically demanding than the projects that defined, maybe the earlier era of FLNG and FSRUs?
I think what we're seeing now is a lot of very shallow water natural gas production. What we see is a lot of gas on land being exported by pipeline to floating facilities just offshore, and then the gas being liquefied on board those facilities. So because of that, they are close to shore, maybe in water depths 20 to 50 meters. And that always puts it in the challenging range of mooring design. But in addition, you could be in a harsh environment, and that leads to even more challenges.
So, where do conventional design assumptions start to get challenged when it comes to this?
Well, I think mooring design, just if you look historically over the 30, 40 years and more that we've been designing FPSOs and FSOs, they started in shallow water. So the expertise of the industry was always in shallow water, and we expanded to deep water. So when we look at these moorings, we see effective moorings from 20 meters to well over 3,000 meters today. With FLNGs, because of the large amount of production equipment and storage capacity, the vessels tend to be extremely large. So if you look at a typical large FPSO, which may be 300 meters in length, an FLNG could be 1.5 times that length. And so when you place such a large vessel in shallow water, that's where the challenges occur. And you have to be very careful to design a robust mooring system because you are handling gas coming through the flow lines. And you also need the reliability because when you're producing LNG, you're producing energy for the world, and you need to continue to make sure that you can deliver gas effectively.
And Matt, let me bring you in from the ABS side on that. What changes when a floating gas concept moves into water depths or operating conditions that are tougher than the industry's, maybe sweet spot?
There's a lot of experience around working in deeper waters with larger vessels, but when we start moving facilities like FLNGs and FSRUs near shore, it brings, like Arun said, some differences in the mooring challenges in front of us, but as well, other opportunities in the variability of the design. When things are in deep water and they're offshore, the fuel systems and the opportunities for power supply are pretty straightforward and limited, whereas when you have a near shore terminal, whether it's a FSRU or a FLNG or an export terminal, you have other opportunities for local power supply. Am I going to get, electricity from land-based supply on a cable coming on board? What other opportunities are there for connecting it to a shoreside plant with remote control opportunities? And those opportunities bring challenges and risks. So if I have power supply for a nearshore vessel coming from shore, what happens if the shoreside power plant goes out? What are the alternatives for power supply? If I have remote controls nearby on a land-based facility, what redundancies are built into those remote controls? Are those controls cyber secure? So it brings in a lot of new opportunities, but a lot of new challenges, and we need to look at those risks and make sure that we're mitigating them safely.
I'm sure there's a tangent we could go down about nuclear energy and how we could apply that there, but we won't do that today. So, we started technical, but I want to kind of take a step back and look at the big picture. Obviously floating gas is a hot topic right now. Arun, where do you see kind of the biggest opportunities for floating gas right now?
Of course, with the situation we have in the world today, I think, and what we've had over the last 5 years, there's a renewed interest in getting energy security from the non-traditional areas. So we're seeing a lot more development off the coast of the US, and we have seen that for quite a few years. We are now looking at nearshore floating facilities off the coast of Louisiana. There's a project in its final stages before FID. We see a lot of activity in Argentina. There are plans for 2 FLNGs and a third one possibly. There's opportunities in Africa. Nigeria has a lot of gas, and there's a lot of talk about floating LNG in Nigeria. We're seeing it pretty much all over the world where there are large gas resources and no access to an LNG plant on land.
And Matt, from your perspective, what's really creating those opportunities for the industry right now?
I mean, we're definitely seeing at a macro level a continued increase in the activity in offshore LNG projects. 10 years ago, one FLNG project was very, very exciting. Today we get 2, 3, sometimes 4 a year. 10 years from now, we're going to be having 8, 9 a year. The global demand for LNG as a fuel is continuing to increase. And we have an opportunity, like Arun said, to capitalize on some of these emerging geographies that haven't traditionally been LNG supply hubs for the rest of the world. And as the demand for energy continues to grow around the world, LNG coming from one part of the world to another that doesn't necessarily have it is going to continue to be a growing business.
So, let's kind of pivot a little bit back to the technical aspects. Arun, at what point does mooring stop being a supporting system and become a major factor in whether a floating gas project is even viable?
So when we look at FSRUs and FLNGs, traditionally FSRUs have always been moored alongside a jetty. And when they're moored alongside the jetty, we use a jetty mooring, of course, and the transfer of fluids is relatively straightforward. That falls outside what we call offshore technology. It's more what's commonly used in ports. We have seen some FLNG units moored in a similar way. The difference with FLNG is they are meant to be moored permanently, so the mooring designs can be very challenging. We're seeing mechanical hydraulic designs being used. Quayside, there are other alternatives, but the majority of these facilities are usually located away from the shore. Maybe the NIMBY effect, people don't want it in the port. It creates a lot more marine traffic if there is a floating facility in the port that's like that. So then we start seeing them move further offshore, especially if they're using gas from land. So those tend to be relatively shallow water.
And man, I think Arun kind of answered this question a little bit already, but what are the key mooring and station keeping questions that become more important in shallow water and harsh environments?
I think the one thing that's very interesting about this beyond the technology itself is that when you take an asset that we as an industry are used to managing in deep water, and we are now near shore, whether it's quayside or gravity-based, the regulatory scheme around that technology changes. And so where we are traditionally used to dealing with International Maritime Organization requirements, class requirements, U.S. Coast Guard, for example, in the United States requirements, when something would be near shore or quayside or gravity-based right on the beach, the entire regulatory scheme changes many times. And you have to consider, all right, now am I talking about a land-based terminal with FERC, or am I talking about a floating facility with a normal flag stake? So it's project by project. One of the key pieces that you need to remember when you're looking at a shoreside or nearshore facility is the regulatory roadmap for a project like this very different than what we're used to dealing with as an offshore industry?
And of course, that leads us directly to the disconnectable side. So Arun, for listeners who may not be familiar with the concept, what problem is that disconnectable submerged yoke system designed to solve, and where does it become especially valuable?
So if we go back to traditional disconnectable systems in the industry, we've been building disconnectable systems since the early 90s in hurricane environments, typically in deeper water. And in those particular systems, we're able to disconnect a buoy from the vessel. It settles maybe 30, 40 meters below the surface, supports the rises, the vessel sails away. And it's well outside the range of the major wave action. It's relatively well designed. When you look at a yoke system, it's a mechanical mooring system because the water depth of 20 meters, coupled with the large vessel and severe environmental conditions, don't allow you to use the catenary system. The other part, before we get to disconnectable, that's so important on FLNGs and FSRUs, from a mooring perspective, is the ability to maintain a heading that allows vessels to offtake from the FLNG or to provide gas to the FSRU. When you look at FPSOs, we are typically lifting our cargo through tandem offloading, and the vessel tends to be aligned with the weather. However, for FLNG and any gas transfer, you're usually doing a side-by-side operation. Those sea states under which it performs that operation are much more controlled. It's a lot more challenging, typically need 3 push-pull tugs to put it in position. And if you're at a fixed heading in the open environment, that can become quite challenging. You may not have the availability to offload. So with a single point mooring, if you have a thruster system, you can actually rotate the vessel to create a lee and provide the best heading for offloading and really increase the availability. And we have seen this in the industry. Most of these facilities are supplied with that. Coming back to the disconnectable, it's a single point mooring system. It's a system that's located on the bow of the vessel. But we've got to lower the mechanical mooring, so it's basically a large clump weight that rotates around a point on the seabed. You've got to lower this clump weight safely on the seabed. If you're familiar with the seabed in the Gulf, it's typically like jello or really sticky clay stuff. You put this 1,500 ton weight on the seabed, you may never be able to pick it up again. So you've got to lay it down on a foundation that supports it, and then you've got to put the rest of the mooring components, this time's chains, lay them out in a way that you can pick them up. Then we can't forget about the flow lines that bring the gas to the plant. You've got to lay those flow lines on the seabed as well while the vessel is departing the mooring system. So that requires some care. We have clump weights that we would use with the flow line to ensure it stays on the seabed when the waves go past. Because in 20 meters, hurricane waves are stirring up the soil, and there's a lot of activity on the components on the seabed. So this is what raises the challenges, because you've got to come back. Hopefully everything's still in place, pick it up and make that connection.
And Matt, let me turn to you on the trust factor. This is something we've talked a lot about on the podcast quite a bit, trusting new technologies and, whatever ways, processes of doing things. So, from a class standpoint, what has to be demonstrated for this system so that it can move from like an interesting idea to something that can actually be trusted in operation?
Well, there are existing class standards and existing regulatory standards for how disconnectable systems work. And in each geography, there are different statutory requirements as well, the requirements for the vessel itself. Okay, this is a disconnectable asset. Is it self-propelled? Is it moved by tugs? How does that work after it disconnects and it needs to, for example, run away from a hurricane? There are existing standards for the aspects of all of those functions. Sometimes, though, the challenge is when you've got an asset that's in a unique situation that no one's ever built before, how do I organize all those statutory requirements to make it applicable to this particular project? Sometimes that's a conversation just with class, but many times it's a conversation with many statutory regulators as well. And that's where one of the opportunities to work with ABS can be helpful to the project, in that we have existing relationships with all these regulators. We're able to act a little bit as the musical conductor, bringing some of these teams together and building a full compliance plan across class, across statutory, across flag state and coastal state, so that we've got one scheme that the project is subjected to.
So, what does industry confidence depend on most? Is it the analysis, testing, operating history, or is it all of the above?
I mean, there's always has anyone built this before question. And when that hasn't been done, many times what the industry does is it looks to an agency like ABS and says, ABS, I want to see either an approval in principle or a basic design approval that says, yes, I don't see anything that's a showstopper on this project, as a class society who's got a lot of experience around floating offshore assets, whether they're nearshore, whether they're offshore. So a lot of times that license to operate or license to move closer to FID would come through an agency like ABS or a company like ABS to provide a little bit of confidence to the project and have some further conversations with those investors.
And I can add to that a little bit. We worked with ABS very closely on our MV-34 off Mexico. It's not a submerged yoke, it's actually a tower yoke for an FPSO in 34 meters of water in offshore Mexico. And it was a system that had never been developed in the industry before. And we spent about a year working with ABS before the project award to just help us identify all the challenges that we may have and look at it from their perspective of what we needed to make sure we had in terms of reliability, safety, and also meeting the requirements for the client. Unlike a typical disconnectable system when you can drop things on the seabed, for the tower yoke, because the mechanical system is above water and very close to very sensitive equipment, you have to be very careful in what sea states you can disconnect and how you disconnect. And I think working with ABS was extremely helpful both before and during the project. And in fact, we are still working on how we could better improve the disconnectability with the facility now in operation.
And, Matt, you mentioned has this been done before? So I think that's where FPSOs come in. Arun, what are the most important mooring and station keeping lessons from FPSOs that transfer directly into that FLNG and FSRU world?
So the good thing is that when you look at a mooring system for an FLNG, so we look at two sides of it if it's single point mooring. One is the load transfer, and that's what we've been talking a lot about, is transferring load, mooring the facility. That is almost a one-to-one connection to what we do with FPSOs. Really no difference. They both need to be reliable. They need to be robust. They're designed to the same criteria. But you also have a fluid transfer system. And the fluid transfer system is important. We also can borrow from FPSOs because most large FPSOs with fluid transfer systems in the mooring have to deal with gas. Gas is always associated with oil. We have to both bring the mixed fluids in, and we either export or we re-inject the gas. So we do have all the technology to handle gas. It's just the amounts of gas we may have in a floating LNG could be very large. 600 million scuffs, 1,000 million scuffs of gas per day. On the other hand, on an FLNG mooring, you are just importing the gas into the facility. The export occurs through offload. So in many ways, the fluid transfer system is relatively straightforward. You've got to transfer a large amount of gas. If it's coming from pipeline where the pressure is controlled and the gas properties are controlled, it's just a large fluid transfer system, not too much challenge. But if you are operating from a subsea system, then you have to worry about all the offset conditions due to the pressures at the reservoir, and that requires a more complex fluid transfer system. We have delivered now 4 FLNG systems, and we're working on our 5th. And we have been able to leverage the technology that we've developed for FPSOs to FLNGs. Sometimes because the vessel is larger, the mooring components get larger, and the number of swivels and the amount of gas we're transferring is more. But other than that, it falls within the standard technology.
And Matt, where do those FPSO lessons carry over cleanly? And where do gas applications introduce different class or design considerations?
I would agree that with what Arun said, and that in general, what we're taking is existing technology and adapting it to a gas environment as opposed to a hydrocarbon environment. But there are changes, there are new things that we're doing relative to FLNG and FSRU that we haven't done too much in the past on FPSOs. And as ABS, as an agency that both writes and verifies compliance with technical standards, the hardest technical standard to write around, it's the hardest subject to write around is innovation. How do I write a rule for something that hasn't ever been built yet when we don't know what the failure modes are? So that's been one of the major focuses of ABS for the last 5 years, is moving our requirements toward goal-based standards. That instead of saying you have to build it this way, we say we have to make sure it functions safely in this way, and how we verify that it functions safely is different than how us saying it needs to be built just like this. And so the application of goal-based standards is really intended to address the ability to mitigate risk around innovation.
The question then becomes how to apply those lessons early enough to make a difference. So Arun, if a developer is looking at a floating gas project in a harsher or shallow environment, what has to come together early for that concept to become genuinely viable?
So if I take one example that we've worked on, we first worked on it in 2015, and we came up with a concept, looked like it worked, had never been built before, but then the project, what we see in floating LNG, many of these projects, especially the ones that were considered in 2015, take a long time to develop. You've got to get the regulatory approvals, you have to get the financing. The market for gas was not necessarily stable. We can keep talking about we need gas for the future, but that decision-making process and financing is quite difficult. What that gave us was time. So we have come up, I think, over the last 10 years with several concepts, and we keep going back and rethinking, how would we do this because again, as has been mentioned, we're dealing with new technology that has not been done before, working with regulators who have not seen a facility like this before. And we are really trying to convince ourselves that what we are going to propose will actually work as required. So I think having time, but then working with class. We have worked with class for 6 years now on helping us evaluate from a third-party perspective the pros and cons of what we're proposing.
And Matt, from your side, what tends to separate those interesting concepts from something that can have real confidence from stakeholders?
Yeah, that's similar to expand on Arun's comments. It's about planning, right? The projects that are the most successful are the projects that have the plan in place early. And when we make changes late in the project, those changes are very expensive. And so working together with companies like ABS and as well as the statutory regulators to make sure that we understand what the plan is for executing the project and that we understand how that's going to influence the specification for design and construction is very, very important. And like Arun said, the best way to do that as successfully as possible is to do it as early as possible. All the comments about the value of prior planning are very, very valid here.
What is it? Failing to plan is planning
to fail. That's right.
So, just to kind of wrap us up here, I was hoping to get some closing thoughts from each of you. Maybe one key takeaway that you want the folks here or out in digital land to take away from this episode. So, Arun, you want to go first on that?
I think we're in a very exciting time, at least from technology development and technology deployment for floating LNG and FSRUs. We're seeing a lot more interest in gas, closer distances to Southeast Asia, which have seen the brunt of the challenges with natural gas lack of supply, closer distances to Europe. And so this opens a lot of opportunities in Africa. We're seeing a lot of work in South Africa now, off Mozambique. But I think as we see this, there's opportunity for gas and with that, stable supply of energy for the world.
And Matt, closing thoughts from you?
Yeah, similarly on the market, I think we're in a time of change right now. The global demand for LNG as an energy source is going to continue to grow. We're seeing that at ABS just based on the number of conversations we're having with people about new projects. But the global supply chain and the global value chain relative to natural gas is in flux right now. Some traditional suppliers are limited in their capacity to provide the gas that they normally have. And there are new emerging geographies that are coming out that are going to be major global suppliers in the future. I mean, just here sitting in the United States, a lot of the projects that we were talking about years ago around gas terminals, the direction of the flow of that gas is changing. And now there's a lot of conversations in the Americas about gas export that 10 years ago we weren't having. And around the world, the changes in the value chain of the way LNG and natural gas is moving from one geography to another is definitely going to be flexible for the next few years. And it provides a lot of opportunity for a lot of people to look at different project opportunities.
Do you have something to add to that?
Just one last thing. When we talk about floating facilities compared to land-based facilities, the time to market executing these jobs is actually a lot shorter. So we're seeing floating LNG systems now being deployed from start of project to completion within 4 years, a lot quicker than a land-based facility. The flip side is that we can't produce as much. Maybe 6 MTPA is maybe the limit, but it can be delivered to the market much quicker than a land-based system because if you're offshore, even though there is a regulatory environment, it's a lot simpler.
Okay, great. Well, I think that's a great note to end it on. So we've covered a lot today, from why floating gas opportunities are getting more complex and more interesting to the importance of station keeping and disconnectability and what the industry is learning from FPSOs. So Arun, Matt, thank you both for joining me for this special episode.
Well, thank you. Enjoyed it.
Thanks, Brad.
And for all our listeners, both here at OTC and virtually, thank you for joining us for another episode of Setting Course. Be sure to subscribe, leave a review, and share this episode. To learn more about innovation in offshore energy, visit us at www.eagle.org. Thank you for listening.